Okay, my apologies for the last video cutting out. Here's the second part of 6.2. Again, working to use StatCrunch. I already have StatCrunch open in another window. But here's my question. I've got heights of women at a college. They're approximately normally distributed. I'm always going to stop right there because I know as soon as I hear normally distributed, I'm going to draw my normal curve and then go back to the rest of the question. They have a mean of 66 inches and population standard deviation of 2.5 inches. So just using that information, and I think I already forgot it, mean of 66, standard deviation of 2.5. So 66 inches and standard deviation of 2.5 inches. So the mean goes in the center, 66, and this is women's heights. Every time you're drawing your graph, label what your data is. Okay. Then my standard deviation, one standard deviation is going to occur where that concavity starts to change. So I'm going to add 2.5 to the 66 to get 68.5 on the right. I'm going to subtract 2.5 on the left to get 63.5 inches as my one standard deviation below. And then I can continue with that same distance. If I add another 2.5, so let's add, I can do that, 6971, right? The easier way would have probably been just to add 5 from here because that's 2 standard deviations. And on the left-hand side, my second, it's actually probably a little further down the road, isn't it? I gotta fix that. So a little further down here would be 61. Okay, so now I've got my data on the x-axis, and I'm now going to look at what they want from me in the question. So in the question now, they want to know what height is at the 10th percentile. So the 10th percentile. The 10th percentile is the data value. So this would be the height of a woman who 10% of women are shorter than her. So not very many women are shorter than her. So this is actually going to be a lower height. So the 10th percentile in this case is the height for which 10% of women are less than that value. And similarly, you could think of it, 90% of women are taller than that height, whatever that height is, than the 10th percentile. So I can already see that I'm going to be on this end of the spectrum. Now let's remember our empirical rules. From our empirical rule, we know that 34% of the data lies in this region right here. That's from the first standard, within the first standard deviation, 68% of the data. This is only half of it because we're on one side. So that's where the 34% comes from. So I can then realize that, well, 16% of the data is below here. Why? Because 50% is from the mean. So 16 and 34 make up the whole 50%. So what that's telling me is that this first standard deviation, that's the 16th percentile because 16% of the data is below it. And then also from the empirical rule, 2 standard deviations from the mean makes up 95% of the data. So if you think about it, 95% of the data is within here. I'm just going to get rid of that little bit. Is within 2, so that means 5% is outside. So in this little crevice and this little crevice over here, that makes up 5%. So half of that would be 2.5. So this 61 inches, that height 2.5% of the women are less than that in height. So if they're looking for the 10th percentile, then I know, I'm going to mark it here in red, that my 10th percentile is going to be between the 2.5th percentile and the 16th percentile. So I'm looking for a height that is somewhere in there. And notice what I know is that less than that amount this one is 10% of women. So the green are benchmarks for the empirical rule. The red is the actual probability that I know. They're telling me that 10% of women have heights less than whatever this height is. And right now I can tell you that this height is between 61, and 63.5. Well, now let's use StatCrunch to get it. So going back to StatCrunch, we have to set our mean. Our mean is going to be, hello mean. Our mean is going to be, I think I said, oh shoot, now I can't remember, 66. Yeah, 66 was our mean, and our standard deviation was 2.5. It'd help if I wrote these things out beforehand. And now, what I've, on my drawing, I know that the data was less than, but I didn't know what amount it was. So I'm going to leave that blank. But I know that the probability of a woman being less than whatever this value was, the 10th percentile, that probability is going to be 0.10. Oh, it didn't take that. It took that as a no. 0.10. There we go. And then I just push compute and voila. This looks a lot like the graph I had before. The tails on the left, there's my shaded area of 10%. And I now know that that woman's height is we'll round to 72.8 inches. So I go back to my graph and I now know that X is 72.8 inches. Makes sense, right? It gets right between those two values. So that's how you're going to use StatCrunch when you, I just want to make sure we understand. When you're looking at StatCrunch, the data is here. So these are whatever you're measuring in data, as far as data. In this case, it was heights. The other question, it was test scores. But the probability, which is represented by the area in the curve, that's always going to go on the right-hand side because this whole thing represents the probability is here. Your mean standard deviation is going to be all right. Notice I could also take a look. What if we wanted to know the chance of a woman being between 62 and 62 and let's say 68 inches? I could compute that, and it gives you also, just by clicking the between up here, you can change to two different boundaries. And then that's a 73% chance that you get a woman who's between 62 and 68 inches. I know I am. All right, so hopefully you've got that StatCrunch calculator open. Again, it's in Stat under Calculators, and you want to go to normal when you're using a normal distribution. We're going to get some other distributions later, but hopefully this will make things easier for you. Have a good night.